Hi, welcome back. In this unit, we're going to look at reviewing how to simplify radicals. This first day, we're just going to simplify basic radicals. We'll look at what happens when we have exponents involved, and then we'll also look at multiplying with radicals. Okay, and then we're going to use that in Pythagorean theorem, 30, 60, 90, 45, 45, 90 triangles. Okay, all right, now, a couple things about radicals that we need to know. I'm not going to spend a ton of time on this. You can always pause it and take the rest of the stuff down. But different radical basics, we got to know the terminology. The coefficient is going to be the number, the expression, I shouldn't just say number, the expression that's in front of the radical. The radical is the actual square root symbol. The number that's underneath the radical is called the radicand. Okay, so make sure that you know those terms because I'm going to use them throughout the year. All right, now these are some perfect squares that you need to know. These are ones that you need to have down because there will be part of your test over this unit that I will not let you use a calculator. And so you need to make sure that you know these specific ones. And I'll go through these here for you real quick. All right, square root of 1 is just 1. And these just go in order. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. Square root of 36 is 6. 49 would be 7. 64 is 8, 81 is 9, square root of 100 is 10, 121 is 11, 144 is 12, 169 is 13, 196 is 14, 225 is 15, 256 is 16, 289 is 17, 324 is 18, and I got to scroll this down if you need it, those top ones, and you can pause it and rewind it. Square root of 361 is 19, and square root of 400 is 20. Again, now you need to know these perfect squares and the squared. So if I ask you on the test, what's the square root of 19? What's the square root of 17? You need to know what those are. Okay, so make sure you know this table. Anything outside of 20, I'm not going to make you memorize that. I'm not worried either way. But the perfect squares 1 through 20, you need to make sure that you know those. Okay, you know 1 through 20 squared, and then know the square roots of those numbers that are on there. All right, so whenever we simplify a radical, it's in its simplest form when a couple things have to happen. No radicands can have a perfect square, and that's either with a number or with a variable. Other than 1. No radicals contain fractions, so no fractions. The entire fraction cannot be underneath the radical. We'll look at an example when it can be a fraction, but you'll notice the radical is not completely underneath the fraction is not completely underneath the radical. And there can be no radicals in the denominator. Okay, so let's look at some examples here. Simplified would be like this first one, 2 times the square root of 3x, square root of 15. Notice this fraction I said up there, what do you say, Coach? You said no fractions. However, the fraction is only, it's a fraction. The radical is only for the square root of 7. The 3 is not underneath the radical. So that's the difference between this other one down here, the square root of 3/4, because 3/4, the entire fraction is underneath the radical symbol. Very, very big difference. Not simplified, square root of 9x squared. I can take the square root of 9 and get a number. I can take the square root of x and get x. So that can be simplified farther. 24 is 16 times 16, I apologize for that, not 16 times 3. 24 is 4 times 6. Well, 4 is I can take the square root of 4, so that can be simplified. Okay, all right, so let's look at a couple of examples on how to simplify here. All right, so we want to factor, there's 2 different ways, and I don't care which way that you use, you'll find a way that you like the best, and there's also, depending on the situation, you might use one more than the other. So I'll factor the same number, and we'll look at 2 different ways to do it. Okay, so we can say the square root of 19, I can rewrite that as the square root of 9 times 2. Okay, so I just spread 18 out, and it's 2 factors. Now, my factors need to be perfect squares here. Well, I can separate that one more time to where I have the square root of 3 times the square root of 2. We'll talk a little bit more about multiplication later, but I'm sorry, not square root of 3, I'm getting ahead of myself. Square root of 9 times the square root of 2. Okay, so I can separate it that way. They both still have the radical. I can take the square root of 9, it's 3. I cannot take the square root of 2 and get a whole number. So I'm just going to leave that just like that, and that is simplified. Okay. Again, depending on how comfortable you are with numbers, simplifying by perfect squares is very simple. All right, so let's say you want to do prime factorization, little factor tree. This is probably how you were taught in middle school. So square root of so 18. I know that it's even, so 2 goes into that. It's 2 times 9, and then 9 is 3 times 3. Okay, so and then I'm looking at these numbers outside here. These all need to be prime numbers. So 2, 3, 3. Okay, so they're prime. I'm going to circle the pairs. So I got a pair of 3s. The pair goes outside. The number that's left over goes inside. And that's it. That's how you factor terms. Okay. All right, so let's look at a couple of other examples. We're not going to go through and do all of these. I'm just going to do a couple. Let's do the square root of 80 here. Again, there's 2 ways to do it. I'm just going to go ahead and use the factor tree real quick. So that's going to be 2 times 40. 40 is 2 times 20. 20 is 2 times 10. And finally 10 is 2 times 5. So I'm going to circle my pairs. I got one pair there, and I got another pair there. Okay, so unlike the first example, now I've got 2 pairs. If I have 2 pairs, I'm going to multiply them together. So 2 times 2 is 4. That goes outside. And I have a 5 left over by itself, so that goes inside. And if I had multiple numbers, let's say I had a 5 and a 3 and a 7, or multiple terms that didn't pair up, I would multiply all of those together as well to leave that on the inside. Okay. All right, we're going to look at 2 more examples, and then that will be it for this video. And I'll create another one here for multiplication and division with square roots, with radicals. All right, so let's look at this one, square root of 27x squared. Okay, so I'm going to look at this as 2 different things. I'm going to separate this into 2 separate things. I'm going to look at just a square root of 27 times, and then I'm going to do the square root of x to the 6th. Okay, so I'm going to look at them completely separate and then combine my answers at the end here. So 27 is 3 times 9. 9 is 3 times 3. I have a pair of 3s. So the pair goes outside. The leftover number goes inside. So now let's look at my x to the 6th. So let's think about this. X to the 6th is x times x times x times x times x, and one more. And this is just like what I did with circling my pairs. If I circle my pairs, there's 1 pair, there's 2 pairs, there's 3 pairs. So the square root of x to the 6th is x. X times x times x. Remember, we multiply x as we add the powers. So x to the 3rd power. I've got nothing left. I've got no other powers left over. There's nothing else going on there. So there's nothing that goes underneath the radical. So it's just x to the 3rd. So now I need to combine these 2 here because I don't want to leave them just separate. So outside my radical, I've got this 3, and then x to the 3rd. And then underneath my radical is 3. And that is how you simplify a radical. Okay, with an exponent. All right, now I want to keep the video fairly short. If you have any other questions in class, let me know, and tomorrow I'll do a couple of extra examples. Okay, I'll do a couple more of these simplification ones. But otherwise, that's it for these set of notes. I appreciate you watching. The next video will be over how to multiply and divide with fractions, and it should be significantly shorter.